build steps, and strengthen the part. More info can be found on BJB's website. After the epoxy is cured, we start to sand the surfaces smooth. Once smooth, we use a high-filling primer to find and fill any low spots on the pattern. A few coats are applied and allowed to dry. Using fast-drying glazing putty, we fill any minor imperfections on the surface. Once dried, we sand smooth and apply more primer to the surface to finish sealing. Depending on the desired surface of the cast parts, you could apply a glossy or textured paint finish, or simply smooth the primered surface with 400 to 600 grit sandpaper to make your mold. In this particular case, we've chosen to smooth and sand the primered surface. Now that we've got our pattern ready to mold, we'll begin the process of mounting it to our splitter board. Because of the inner detail and many sharp corners that could trap air, we'll plan to cast the bottom half first and add our vents to the second half. The majority of our split line will be flat against the splitter board, but there are a few sections that will require making a block to close the gaps and define the split line. Using some particle board, we trace the inner diameter of the opening. We rough cut the shape of the plug on our bandsaw. The plug is carefully sanded closer to shape on a sanding wheel. The sharp corners are rounded off by hand using a sanding block. And lastly, we seal the particle board with our filled primer and sand smooth. To make this smaller plug, we found a piece of plastic dowel that matched the radius. We cut it to shape on the bandsaw and sanded the edges smooth to remove any sharp edges. We double side tape the PVC sheet down to the stiffer base. Note that using this thin sheet of PVC makes removal of the splitter board easier later in the process. Next, we trace our pattern onto the PVC sheet for easier centering later. A fine mist of cyanoacrylate accelerator is applied to the PVC. Using a piece of wire, we apply small dots of cyanoacrylate glue to the bottom of our pattern. We want just enough glue to hold the pattern down, but remain easy to remove later in the process. Once the glue is applied, we carefully set the pattern down onto the splitter board using our traced outline as a guide. Next, we place our larger plug in the hole and glue in place. We then place the smaller plug in the hole and glue it into place. Using non-sulfur, oil-based modeling clay, we begin to fill any minor gaps around the plugs. Small sculpting tools or handmade tools work well for this task. Now that our pattern is securely mounted to the splitter board, we can begin adding our registration keys. Once again, small amounts of CA glue are used to fasten them down to the board. We've made sure to leave a little space between the pattern and surrounding mold box. The mold box is placed onto the splitter board. The entire perimeter is fastened down with a bead of hot glue, ensuring a complete seal to prevent silicone from leaking out after it's poured. It's time to measure out our 2-part silicone material. Watch our intro mold making video for more details on measuring and mixing molding silicone. Pulling a vacuum on the mixture ensures the extraction of a majority of air bubbles. Pour the silicone in a thin stream away from the pattern, allowing the flow of material across the geometry and pushing air out of the way as it flows. Any residual bubbles should rise to the surface and pop on their own. After sufficient cure time of the silicone, we begin to remove the splitter board. A good tech tip is the use of isopropyl alcohol to loosen the bond of the hot glue. After a moment to soak, a scraper easily removes the bead of glue. We wipe dry any remaining alcohol from the surfaces. At this step, you'll clearly see why we use a thin sheet of PVC instead of a thicker, stiffer board to mount the pattern. A little flexing around the corners breaks the splitter loose and it comes off without a fight. Next, we remove the plugs from the silicone and pattern. We then begin to clean away any clay or flashing from the silicone. Using a non-metallic, sharp plastic scraper does a great job to remove the silicone flashing that has wicked its way under the keys and mold box. The registration keys are then removed from the silicone to reveal a pocket. The edges can be sanded smooth with 220 grit sandpaper to remove any additional flashing. Once the first mold half is cleaned up, we can prepare to add our vents and fill port. To locate them, we need to establish the optimum orientation of the mold during the casting process. We've determined that putting a fill port here and distributing vents outward toward high points will work very well for this part. We apply a mist of CA accelerator onto the pattern to make our vents bond on contact instead of fumbling for the spray bottle later. Dispense a small amount of CA glue onto a pad and dip the ends of the vents before placing onto our pattern. We typically put a vent at any high points, trap corners, and between any long stretches. Our fill port is placed at the lowest spot around our split line. Before the mold box is set in place, we will apply a mold release to the deep registration channels using a brush. This also works well for undercuts or other areas that would be difficult for the spray can to reach. We can then place the mold box onto the lower half of the mold. Hot glue is used to seal the two halves together and prevent liquid silicone from leaking out once poured. Lastly, we apply our mold release to the exposed surfaces to ensure the two halves separate later on. Remember, silicone will bond to itself, but does not bond to plastic surfaces. Our silicone molding material is measured out, mixed, de-aired, and ready to pour. We are careful to pour slowly so our delicate vents don't get knocked over by the flow of the silicone. The mold is filled to a minimum thickness that will provide enough support for the particular mold size, but not higher than our vents and fill port risers. Once the silicone is cured, it's time to remove the vent and fill port risers. A light twist is all that's needed to break the bond loose. Once again, we soak the hot glue with isopropyl alcohol and remove the bead of glue. The mold boxes are carefully pried apart around the perimeter. The top mold box easily lifts off and is set aside. The bottom mold box is thicker and requires us to remove one wall to get it off. We slowly start to peel and pry apart the split line of the silicone mold. Once we make our way around the perimeter, the halves easily separate. The mold is flexed from various angles to assist removal of the pattern. Here we begin the process of making a top plate for our mold. The benefits of making a top plate are reduced flashing and increased accuracy of the part. This is because the top half of the mold can't swell upward from internal hydraulic pressure as casting material flows through. And the larger the mold, the more pressure there is. Once our mold top is finished, a generous coating of petroleum jelly on the exposed wood prevents overflowed casting material from sticking later. Before we cast into our new mold, we want to apply an appropriate mold release. Rocket release is considered a paintable mold release, meaning any residue transferred to the cast part can be easily washed off later. Avoid silicone oil-based releases if you plan to paint the part. Allow any solvents to flash off prior to closing the mold. We set the mold top on and secure it in place with tape. A couple of wraps is all that will be needed on a smaller mold like this. Next, we grab a handful of plastic straws and begin placing them in the vent holes. As mentioned in our other video, these will serve as reservoirs to account for any shrinkage, and they also prevent a mess from overflowing material. Finally, our funnel is securely placed in the fill port. A block of wood under the corner angles the mold up towards our intended high points. Now it's time to mix up our casting polyurethane. We've chosen a rigid, high-impact material, TC874. Once the product is mixed, we place it in our vacuum chamber to remove the air bubbles. After 30 to 40 seconds, we can stop the vacuum and remove it from the chamber. The urethane is carefully poured into our funnel and flows through the mold. You can see the material starting to flow out the vent risers, meaning the cavity is being filled. We then move our mold into a pressure pot. As mentioned in our other video, pressure casting is an optional but popular method that aids in reducing any incidental bubbles that get trapped in the mold geometry. Common pressures used are in the 50 to 60 psi range. Once the polyurethane has had time to cure, we remove it from the pressure tank. The tape holding the mold together is removed. Then the process of removing the fill port and vents can begin. A quick twist with pliers easily removes them. The mold can then be slowly pried apart at the seam to begin part removal. The silicone mold half can be flexed to break the part loose and finally removed. So here are the assembled cast parts after painting, ready for the installation of electronics and used for product testing in the real world. Or it could be the final product for sale. BJB manufactures castable polyurethanes that feature a wide variety of properties: rigid, flexible, tintable, fire retardant, and so on. As you can see, casting polyurethane parts from silicone molds is a great complementary process to 3D printing. This method is how product development and short to medium run production has been done for years. With the proliferation of affordable 3D printers in the hands of students, engineers, and entrepreneurs, you too now understand its value and ability to take your designs to the next level. Now that you've seen the video and we've helped take some of the mystery out of materials, you also found the source for high-quality casting and mold-making products. For questions regarding material selection or process help, feel free to contact us by phone, through our website, or post in the comments below. Be sure to check out other helpful videos from BJB, and thanks for watching.